Hello, once again, ladies and gentlemen, and welcome to our virtual meeting. Today, we're going to do things just a little bit differently than what we usually do. In fact, we're going to begin with notes that we did not review, but would have applied to the last lesson. And I am talking about the area and perimeter of squares, rectangles, really any parallelogram. Okay, just remember that any parallelogram, this applies to that. And I don't necessarily want you to copy these down unless you want to. If you notice, there's no, I didn't put a number above these. They will be found in the same notes or folder as composite figures. We are going to take some notes in a little bit, but I just want to cover this quickly. And so let's begin with the word perimeter. All right, let's review the word perimeter, which we did use last time. And the word perimeter is actually also a compound word. It's the word or the prefix peri and followed by the word meter. And peri, you'll see this a lot, especially in medical terminology. Peri means around. Peri means around, like the pericardium, which might not mean anything to you guys, but cardium means heart. Peri means the area around the heart. Anyways, peri. And meter means length or measure, and you guys should know that already. And that just means length or measure. So perimeter means the distance around a figure. It's the distance around a figure. And in a rectangle, parallelogram, rhomboid, the way that we find that, ladies and gentlemen, is simply by adding up all the different lengths. You just add them up. Now, the advantage that we have here is that knowing one of the lengths, or really two of them, you can get all four of them, because in any kind of parallelogram, opposite lengths will be the same. So 4, if this top part is 4, then this bottom will be 4. If this side part is 5 meters, then the one across will also be 5 meters. And so 4 plus 5 is 9. Plus 4 is 13, plus 5 is 18 meters. That's how we get the perimeter. And again, that's just review. Okay, we're just measuring all the way around. It's like the fence. That is the perimeter. Now, by contrast, area is the inside. And so I'm going to zoom into that very same rectangle that I had up there. Okay, it's the same one. I just made it a little bit bigger. But area is the inside, and the mathematical technical definition of that is it's the number of square units. I know, what do you mean by squares? The number of square units a figure covers, or that make up a figure. It is the space inside a figure, okay? But literally it is the number of square units. What do I mean by that? Well, again, same exact rectangle, it's just bigger. But again, we have 4 meters. So, and I'll do this in the same color. So we have 1, 2, 3, 4 meters. Okay, that's how far it goes across. And I'm going to take those 4 meters and go up 1, 2, 3, 4, 5. All right. So let's see how many squares we actually make by doing that, ladies and gentlemen. Let's see how many squares we make. So obviously here we have our 4, because 4 times 1, only going up. That would be 4 square units. 4 times 1, 2. That would be 8 square units, meters actually. Up by 3 is 12, which makes sense because 4 times 3 is 12. Up 1, 2, 3, 4 would be 16. And finally, up all the way to 5, notice how now we have 20 square meters. Literally, there's 20 squares that are a meter high and wide, 20 square meters. All right, so that's really how we do. We just multiply the base times how high it goes. Base times how high it goes. So 4 times 5, 5 times 4, it's the same thing. So our formula for the area of a parallelogram, in this case a rectangle, it's always going to be the base times the height. And I know that in elementary school you guys learned it as length times width. That is still applicable, but base times height is just a little bit more specific. So base times the height. And so again, base times height, the area is going to be 4 times 5. The area is going to be 20. And we saw this means squared, right? So meters squared. This is just the units right here. Meters squared We made 20 little squares. That's exactly what that means. All right, so having done that, let's go into our assignment really quick. Let's go into our assignment really quick and see numbers 3 and 4. Notice how number 3 is simply asking, what is the perimeter of this shape? What is the perimeter of this shape? Well, notice how right here we have 10 feet. Let me just zoom in a little bit here. We don't need this right now. Notice how we have 10 feet. Actually, we have 10 feet right here. So across this is also going to be 10 feet. And over here we have 2 feet. So across this is going to be 2 feet as well. All right. So 10 plus 10 is 20, plus 2 is 22, plus 2 is 24. So the perimeter would be 24 feet, and just feet, because there's no squares, we just measured it. It's like we took a measuring tape and just went all the way around. 24 feet. And number 4, well, what is the area? Well, we saw all we need is the base times the height. So all we need is 10 times 2. 10 times 2 would be 20. That would be 20 squares. And notice how if I were to cut this like that, and we have 1, 2 feet going this way, we have 20 going, 10 going that way, that would give us 20 feet. And you would put the little square up here, that means squared feet. 20 feet squared. All right, there's 20 little squares right there. So that's it. That's it for perimeter and area. That is what we did last Friday. So now, ladies and gentlemen, let's go into today's actual notes. And so if you will actually take about a minute to copy down the heading, I do want you to copy these down. I did make a mistake again, but instead of 48, this should say 49. This is our 49th lesson. This is our 49th lesson. And this is composite figures. Composite figures, 23-2 composite figures. We already did 3 and 4. That's the ones that we just did, but we're going to do 8 and 9, and then you can do 14 through 17, then 18 and 20 through 22 are bonus. So do copy these down, please. Assuming you've already copied this down, let's go ahead and begin with the definition of a composite figure. Ladies and gentlemen, a composite figure is simply a shape made up of multiple regular shapes. So it can be divided into 2 or more basic figures. So it can be like multiple triangles or a square and a triangle, or some kind of trapezoid or parallelogram, or maybe regardless, any 2 or more regular shapes. All right, that is a composite figure. It is composed of, you see the word composed right here. It is composed of several shapes, at least 2. All right. And so, but before we actually go into some composite figures, let us look at the area of a parallelogram in a bit of a different way. Earlier, we saw the area of a parallelogram, specifically the area of a rectangle. But what if it's just a parallelogram? All right. It's obviously not a rectangle, like we don't see 4 right angles. It's kind of shifted. So it would be the area of a parallelogram. Well, ladies and gentlemen, it would actually be the exact same thing. It would be the base times the height. The base times the height. Well, what do I mean by that? Well, notice how my base is this. My base, I'm going to choose this to be my base. All right. So how long is that base? It is 8 inches. Right. So I put an 8 right here. And what is the height? Now be careful. A lot of you guys would think, oh, well, the height is obviously 5, right, Mr. Lugo? Ladies and gentlemen, that is not the height. Okay, that is not the height. If we were to think this as a diving board, all right, and bear along with me as I do this, all right? If we were to think of this as a diving board, we had a little dude or dudette up here. All right, and if they were going to jump, when they jumped, would they fall straight down, or would they fall like this, and then kind of go sideways like that? Obviously, the height that you need to worry about, is simply, we lost a leg, is simply straight up and down. So that's what makes this the height. It doesn't matter how long this diagonal line is. We still want to measure directly from up and down, just the shortest distance from up to down. So we see that the height is actually 4 inches. All right, from the base all the way to the top, if you were just to measure straight up, yes, that would be 4 inches. And notice how that gives us a nice little rectangle right here. That is why it's just 4 times 8, or 8 times 4. That is going to be the area. And 8 times 4 we know to be 32 inches. And because it is area is always in units squared, ladies and gentlemen. So again, let me re-explain that. again, so we have this parallelogram. We want to get the base times the height. So if we say that this is the base down here, we say that that is the base, the height is going to be the shortest distance from one base to the other. All right, or it's going to be a straight line from the base all the way to the other. Notice how that does make a right angle when you meet the two of them. All right, the height is not going to be the length of the other sides. No, it would just be straight up and down. So yes, it would be 4 times 8. It would be 4 times 8. And so multiplying that 4 times 8, that would give us 32. Let's look at one more. And again, we have the area of a parallelogram right here. I'm going to make these the bases. It doesn't really matter what you make the base, as long as you have a straight line, and we're going to talk more about that later. This is actually called a perpendicular line. A straight line from one base all the way to the other, right? That is going to be the shortest distance, meaning that it's going to make a right angle. So the shortest distance is not 10. It's actually, if I were to take a tape measure, it's shorter to go just straight like that than to go to follow this diagonal line. So my base is 9, and my height, so to speak, I would have to turn it over this way, is 9 also. So 9 times 9. 9 times 9, that would give us 81. 81. Now, if we were talking about the perimeter, then yes, you would get everything around. So 8 plus 5 plus 8 plus 5. But since we're getting the area, we just multiply the base times the height, which had to be given to us. Over here as well, if I was getting the perimeter, I would do 9 plus 10 plus 9 plus 10. But if we're getting the area, we're going to do the base times the height, which would be 9 times 9. So with that in mind, ladies and gentlemen, if you turn to your assignment and actually look at number 8, there we have a nice little parallelogram. And it's asking you, well, what is the area? What is the area of that figure? All right, and again, area is going to be base times the height, the shortest distance. And notice how this is the same as this. So it would really be base times the height, base times the height. So what does all this have to do with composite figures? What does this have to do with shapes that are made up of multiple shapes? Well, for that, ladies and gentlemen, I will make a second video, but I do want to encourage you to look at number 9 and consider that this weird looking shape can be split into multiple shapes. In fact, I see one parallelogram up here with its dimensions right here. I see one rectangle right here. But we see, well, what is this base? We know what this base is. And I see yet another rectangle here, yet it looks a little bit different. And so let's see if you can do that on your own. And I will make a second video where I will explain that in detail. So with that in mind, ladies and gentlemen, I do encourage you to try the rest of the problems on your own. Those are found up here. So 9 and then 14 through 17. And if you're having trouble, I encourage you to watch the other video. And that's it for now, and I will see you in the next video.